Today's notes are on solving systems using inverse matrices. We have already solved matrices using Cramer's rule. Now we will solve them using inverse matrices. Your first step is going to be to write the linear system as a matrix equation. You are going to take the coefficients and plug them in for one matrix. The second matrix would be your x matrix, what we're trying to solve, so with our variables x and y. And the third matrix, B, is what it's equal to. So you can see E and F on the right side of our equation. So our first step would be, or our second step then would be to find the inverse of our matrix A. Then we're going to multiply both sides of the equation by that inverse and solve for our matrix X. After we have finished multiplying, we will have the identity matrix times matrix X is equal to our answer matrix. So let's go through and look at an example here. Example number 1. The first thing I want to do is write this in terms of a matrix equation. So we are going to take the coefficients out front first. So I have -2, -5, 3, and 2. And we're going to multiply this by our matrix X, which are our variables. This is what we're trying to solve for. And it's going to be equal to our two terms on the right side of the equal sign, -19 and 1. So our first step is going to be to find the inverse of A, which means I need to start by finding the determinant. So I have -2 times 2 minus 3 times -5. So I get -4 plus 15, which gives us 11. We need to remember from our notes on identity matrices and the inverses that I then take 1 over the determinant, and we're going to multiply it by the switched matrix. So my diagonal downs switch spots, and the diagonal ups switch their sign. And then we're going to go ahead and multiply the scalar of 111 into each term. So I'm going to get 2 over 11, 5 over 11, -3 over 11, and -2 over 11. This is my inverse matrix. Alright, our next step is going to be to take the inverse matrix and multiply it by both sides of the equation. Alright, I'm going to start by multiplying this by the right side of the equation, the -19 over 1, because we should know that if we multiply it by the left side of the equation, that we should be getting our identity matrix. So if I go ahead and multiply these two together, I get 2 over 11 times -19 plus 5 over 11 times 1. Then for my second row, I get -3 over 11 times -19 plus -2 over 11 times 1 Alright, so if I simplify this, the top one becomes negative 33 over 11, the bottom one becomes 55 over 11, both which can be simplified. This gets simplified to negative 3 and 5, and then because I am writing a system, or solving a system, I need to write my answer as an ordered pair. So your final answer is going to be negative 3, 5. I want to reiterate one more time that you should have multiplied the inverse matrix by both sides of the equation. However, you should know that if you multiply it by the left side here, you're going to get the identity matrix. So really we just need to multiply it by the right side. If you're not sure if you have the right inverse, then you should multiply it by both sides to check. Please try example number 2 on your own and then flip it over and look at example number 3. For example 3, we're going to follow the same steps, but this time we're going to use our graphing calculators to help us. So setting up my equation here, I would have 2, 3, negative 1, 4, 5, 2, negative 1, 3, and negative 4, and that would be multiplied by my variable matrix, and it would be equal to 14, 34, and 20. So the first thing we would need to do would be to find the matrix of, or the inverse of matrix A, and because this is a 3 by 3 system and the instructions tell us that we can use a graphing calculator, you're going to want to follow your instructions on your how to use your graphing calculator to solve matrices sheets to find the matrix, or to find the inverse of matrix A. If you follow the instructions, you should get 26 over 27, negative 1 over 3, negative 11 over 27, negative 14 over 27, 1 over 3, 8 over 27, negative 17 over 27, 1/3, and 2 over 27. If you do not have a graphing calculator, you would first need to find the determinant of the 3 by 3 matrix and then take 1 over that number and multiply it into a switched matrix in order to get your inverse here. Then you would take this inverse and you would multiply it by both sides. So on the left side it should give you the identity matrix. If I multiply it by the matrix here on the right, I should find that our matrix XYZ is going to be equal to negative 6, 10, and 4, which again I want to write as an ordered triple. So this would be my final answer. Please try and do example 4 on your own.